Second one, again, start off by factoring things completely. Bottom is a difference of squares. First thing we look at is our non-permissible values. X can't equal -5, and x can't equal 5. Vertical asymptotes or holes? They'll both be vertical asymptotes. One at x equals -5, the other at x equals 5. Step 2. What is the highest power, the largest degree? X squared. We have -2x squared on the top and 1x squared on the bottom. This simplifies to -2, which means we have a horizontal asymptote at y equals -2. How many of these graphs through section 2.3 and 2.4 have we done now? Is this like graph number 7? You're starting to get a feel for the process? Still shaking your head? No, not yet. Well, we find our asymptotes, we graph our asymptotes. We're going to have an asymptote here and here, one at x equals 5, the other at x equals -5. We have our asymptote -2. At y equals -2. Let's find our y-intercept. Y-intercept is found by plugging in 0 for x. What do we get? 0 over -25, which is 0. So we have the point 0, 0. Let's find our x-intercepts. Your x-intercepts or whenever your numerator is equal to 0. That's equal to 0 when x is 0. So it's the same point, and that's the only x-intercept. Okay, well, we have one point, and that's it. We don't know which way our graph is going to go after this point because remember that our horizontal asymptote is only going to help us in our outer sections because it's when x gets really, really big or when x gets really, really large negative numbers. So in the middle section, it might happen that our graph goes through an asymptote, and we've seen that already a couple of times. So we need to figure out some more points before we can graph things. In our middle section, if I want to find out what's happening when my graph gets close to my asymptotes, is it going to be going up towards the asymptotes or down? I can find that out by plugging in a point close to my asymptote. So I'm going to check what happens when I plug in 4 and -4. Now when I plug in +4, go up to my equation here, can you see that the top is going to be -32? And 16 minus 25 is -9. Whoa. -32 over -9, which is a positive number between 3 and 4. So as far as graphing that goes, 3, 4, I have this point here, do that in green. It is at 4, 32 over 9. Without actually plugging it in, can you see that putting in a negative number when it gets squared will be +16, same as putting in +4. So we're going to get the same point over here, -4, 32 over 9. So now we know that our graph goes up towards those asymptotes and not down, or not up on one side and down on the other. We have now figured out this middle section, but we still need to figure out these outside sections. Again, we'll figure that out by plugging in a value for x. So we'll check what happens at positive 6, what happens at negative 6. Now when I plug in positive 6, can you see on the top I'm going to get 36 times negative 72. And when I plug in 6 on the bottom, I get 36 minus 25, which is 11. That's going to be a number between negative 6 and negative 7. As far as putting that on our graph, I can plug that in here. I have 6 comma negative 72 over 11. Estimate where that's going to be. Because this is on my outside section, I know that it's got to go towards my asymptotes, and it's going to look like this. Does it make sense that plugging in negative 6 will do exactly the same thing? So we are going to get negative 6 comma negative 72 over 11, and this section will look like this as well. Domain and range for this one. Well, the domain is still fairly easy. We have two non-permissible values, so we say x can't equal negative 5, x can't equal 5, but x could be anything else. The range for this one, I don't think they would ask you the range of something like this on a non-calculator part of our exam. We're making an assumption that the graph doesn't go less than 0. I guess we can make that assumption because then it would have more x-intercepts. So 0, 0 has to be our minimum. And if we know that 0, 0 is our minimum in that section, well, our range for the bottom part here, y has to be less than negative 2. Everything less than negative 2 is fine. It can't equal negative 2 because that's where our asymptote is. But then there's this gap in between negative 2 and 0 where there's no y values. Can you see that in this? Ooh, I'll use a blue highlighted section. That there's no y values ever in that section. So our y values start again when y is bigger than or equal to 0. So that's a hard range because there's the two parts, and you have to say this part or the other part. You could write this in interval notation. Say I'll start at negative infinity, I'll go up to negative 2, and then I'll start again at 0 with a square bracket because it's included, and go up to infinity. Questions for practice for this one? Number 4.